And welcome back to Doz's Television Workshop, where we're continuing on with our Colster Brands KV003 black and white TV set from around about 1965. We've got a few faults to look at. We've got low frame height, which may be an adjustment. We've also got low contrast, very low contrast on 625 lines, and the tuning is very touchy. Also, there are a couple of mixed dielectric capacitors in there that might be working fine this week, but who knows what they'll be like next week. So they need to come out and get replaced. Right, let's get into it. Right, we're going to have a quick look at the schematic first to see what we can understand about the 625 line contrast and the height. So we've got a circuit description here. Designed for operation on British television 405 and 625 line systems, blah, 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 blah. Later production receivers are fitted with a T-band CRT. I did have a look at that. Ours isn't. The early type of CRT has no rim band. The later one does. Hence, Darset has a plastic implosion screen in front of the CRT. Right. Separate aerial sockets. The VHF tuner employed in this chassis and the circuit alignment procedure is covered by service sheet. Well, the VHF tuner is working fine. One of the two alternative types of UHF tuners may be fitted, but the makers state that no attempt should be made by the dealers' service departments to repair or adjust the UHF tuner, and that even removal and replacement of the cover plate may adversely affect the unit's performance. Oh dear. Right, so if the problem's in our tuner, we will have very little choice really but to take it apart anyway, so we'll have a look at that maybe. But here's how the sort of IF and vision's working. So signals from the VHF tuner are coupled by a wideband transformer comprising L10 in the mixer anode circuit and L43. So those are the two valves inside the VHF tuner. Now, it might say L10, etc. here, but none of that is shown on this diagram because we need this service sheet, 1715 T228, which we don't have, at least at the moment. However, being as it's working fine on VHF anyway, I don't think our problem's there. So we've got, yeah, so where are we? Bottom, trace the screen lean as C41. L41 is the 405 response shaping coil, and L42, C5 and C46 form the 625 adjacent carrier rejection tuned to 41.5 megahertz. So if we actually have a look at the diagram, you can see it starts with the IF coming in. So this is from either the VHF or UHF tuners. So there's some sort of switching done there to put the right IF in. Then we can see we come into the IF, which is the actual 45 megahertz IF here and here. And I think this is the vision detector circuit here. So V6, let's see if it mentions V6 anywhere, which I think is our vision amplifier. So basic interstage coupling between, and the vision IF amplifier V6 performed by L44, yep. Well, we know that's okay, at least in 405. The 405 and 625 band shaping filters selected by S2 and S3. So let's have a look at S2 and S3. S, by the way, all the switches S are the standard switches. A is 405, B is 625. So we've got S17 there. Which one were we looking for again? Hang on. S2 and S3. 47 and 43. This is where we're interested in. S8 and S9 are switched so that on 405 line, positive going output from the detector is directly coupled to the grid. Now, what that means is positive going. So with the 405 line system, so our switch is in A here and A here. So that's coupled to ground. A, then our vision is coming out of there through this network, out and away and down there. So 405 vision is negative going. Can you see it's a negative rectifier? So this is obviously the cathode, and what that means is the higher voltage we get, the brighter the beam is on the screen. So that's 405, the 405 standard. It has positive vision modulation. The higher the voltage, the brighter the particular part of the picture is. So at the other side, B, you can see this time this side of the circuit is grounded, and we get positive video modulation feeding through C69 onto R62 and then into the vision amplifier itself. That's the end of R62 there, and here we can see the vision. Also, we've got this in here, so B, that's just grounded. C76, what are you doing? A goes through a tuned circuit and then back off. So C76 must be okay, because it's okay in 405, and there is just an extra filter in 405. So 625 comes along. So what are our differences on 625 lines? We've got that capacitor C69 and B. It's about it, isn't it? Yeah. We could have a fault in the AGC as well. Is there any difference in the AGC operation? AGC ends up down here. D1, it's 1, 2, third line in from this side. 1, 2, 3. Does come out of the contrast circuit. So you can see here are our contrast controls. So 1, 2, 3 here. Yeah, there's not a lot of difference in the standard selection there. Standard's obviously switching these two here. So what could we have wrong? If it's in this circuit, and I'm not saying it is, we may have a problem over here somewhere. If it's a problem in this circuit, with B engaged, it could be C69 is open circuit or approaching. R62 is common to both, so it's not that. Or we could have something as simple as R99 being faulty. Right, I am going to look at the locations of C69 and R99 on the layout diagram, and I've got a feeling they'll be in the bottom somewhere. C69 and R99. They're going to be in the bottom, aren't they? Oh, this is interesting as well. Oh, that's a skeletal slider thing. Very cheap and cheerful. Often breaking. That's our height pot. I'll show you that on the camera in a minute. C69 and there's R100, R110, R99. That looks like it could be quite easy to get to. Right, let's get on it. Okay. Here we are. One thing we haven't also considered is the system switch itself. And I'm sort of looking to see where it is. And what we've never done is actually look underneath the set. So also that is, according to the service sheet, where C69 lies. So, oh, these are the skeletal sort of pots, by the way. That one's height. That one's linearity. You can see there's a blob of something on there. They really are a horrible thing. You can see the wiper on that one is just a wire, and you sort of move it along the piece of PCB with a carbon print on it. They're not very pleasant things. Always failing in Decker Bradfords. There was a one for width that was terrible. Right, so this is the underside of the chassis. So here is our system switch. So if I move the standard switch across, you can see all of those contacts shifting about. We've never cleaned that, and it is awfully tarnished in places, and just wonder whether that's part of our low contrast issue. So I'm just going to get a tin of the old magic and give it a little birthday along there. Move that back and forward a few times. KB, by the way, and ITT, their first colour set was point-to-point wired like this, including the chroma decoder. Obviously an all-valve affair. It was quite complicated. Right, this here is C99. It's a Lemco capacitor, 125 volts, 0.22 mic. So I'm just going to get the ESR meter. Oh, this is good, by the way. I 3D printed a little case. This needs tidying up in places, but it takes all the peak instruments, matches the profile perfectly, and just slots in, look. I'll leave the link down below. In fact, if you go on Thingiverse and just type in Peak Instruments, you can print yourself one of those. Very nice. Anyway, we've got the Peak ESR 70 gold. All right, it's meant to be for electrolytics, but you know what? It'll work fine on that value. So let's just get in there, between there and there, analysing 0.26 microfarads, 3.9 ohms ESR. It's in rude health. So that's good news. So now we need to find R99, which is up here somewhere. I'm just going to measure that. Oh, I'll use the old multimeter for that. So R99 is located, it's the second resistor down here. Just lose these probes. And what's the value of R99? I hear you cry. I don't know. I don't know what I'm measuring. R99, according to the service sheet, 4.7 megs. So it's the second resistor down on this tag strip here, which is sort of buried in amongst that filth. So let's just give ourselves something to work with. Ugh. Really needs taken outside, an airline running through it. Right, we've got ohms, sanity tests, we're sane, good. So that should be 4.7 megs. And well, it's risen to 5.5 megs. 4.7 plus 10%, 470k. It's out of spec, isn't it? Well, that might be something. I'll tell you what else I don't like, is that's one of those mixed dielectric capacitors. And that, I think, is on that same tag. Let me just investigate this. There's a bucket of corrosion on there as well. Is that actually connected there? No, it's not. It's connected to that, and that. It's just sat in there. It's got nothing to do with it. Okay. Right. So that resistor's gone high. 4.7 megs. I'm not sure I'm going to have anything that high. Let's have a look in the box. 3.3, 4.3, 4.7. Would you believe it? We've got 4.7 meg in stock. .7 megs. Let's just check it on the meter. Lovely, 4.7 megs. So what we now need to do is just swap that out. I'm half tempted though just to hold fire for a second and power the setup and actually see what it looks like now before we do that, having cleaned the system switch. Let's do that first. The Hedgehog standards converter is on. We're set to 405. Let's just make sure we've not developed any more faults. I'm also going to give the pots on the back here a quick squirt, the contrast pots and the height, not the height, the horizontal and vertical hold, because they were quite scratchy before. A little birthday look. I can hear line whistle. There we go. So good, we're working very nicely on 405 lines. So we were. Very nice. Okay, still got that height problem. We might just give that a tweak now actually. Let me find an insulated tool to move that with, because I don't know how many volts are on there. Let's just, oh my goodness. Almost nothing wrong with this set, is there? Okay. Well, you don't have a height issue anymore. Let us switch to 625 and see how our contrast is doing. Very badly is the answer, of course. So let's... Well, that's interesting. Well, it is making a difference. It's very sluggish. But yeah, there's almost no contrast there at all. We're completely overrun with contrast on 405. Okay, so changing that, just cleaning the standard switch has not affected a repair. So let's change that resistor that's gone slightly high and see where we get to then. Okay. I'm just going to see if I can move this bit of cardboard out so you get a bit of view. No, it's bolted in. The resistor is just tucked in there. What I'm actually just going to do is I'm going to snip him out. Just tack another one in for now. Oh, it's awkward to get at. Okay, that's him out. Let's have a bit of a soldering iron action going on. So it actually runs between that tag strip there and that one there. So I'm just going to tack it in for now. Lovely. That's tacked that in there. Let's spin the set round again and try it out. Right, 625 is in, mains is on, we're drawing current. Let's turn that light down a bit. So, much as before, pots of contrast on 405 and 625, I have to say, is still ghastly. Does look a little bit grainy as well. So that wasn't it. Okay, we move on. Let's go and take another look at the schematic. Okay, I've just spotted something else. Down underneath that R99 that we've replaced is C90, and that is between the video and this, which is ground look. So if he was leaking, we'd effectively reduce the height of our video waveform, which would give us awful contrast. And it's a nasty wax thing. So what I'm going to do is I'm just going to lift it at one end, not sure which end, whichever end I can get out easily, and just leave it disconnected for now. We may get a bit of ringing, but see if that does improve the situation. Let's have a go at that. Okay, so that here is C90. I think it's easiest to drop it off its ground lug here. So let's just see if we can't ease that away. I had a drop of fresh solder on that. It's one of those, is it a waxy? It could be waxy. It's 1000 picofarads, allegedly. So, right, that's flowing nicely now. Really? Yep, he's free. Right. Once again, let's power up and see what happens. 625 line signal. The UHF tuner, by the way, you know, I said I thought it was valve. I don't think it is. I think it's transistorized. So, yeah. No, still as bad. So we've still got horrible washed out video. Plenty of brightness, nothing in the way of contrast. Okay. It wasn't that capacitor, so we can solder that back in. Let's kill the power. Pliers. Must be said, I am dreading an IF fault, but I think that's where we're going next. So what I think we might do now is scratch my head, see if we can remove the tuners, just the IF input into the IF in the bottom of the set, and generate a 41.5 megahertz IF signal with some 625 video on it, drop that straight in, and then see if we've got contrast adjustment. That will at least rule out the tuner. This is going to involve getting that chassis down, and so we can sort of work on that. Okay, right, let's have a little look at that then. So what do we reckon? 2 screws there, the whole thing hinges down. There's a hinge thing there. I think it's going to be something like that. A bit dodgy on the CRT socket. Let's see how far we get. Okay, so there's one 4BA screw right down there. Oh, you can't see much. Just pan out a bit. There you go. So we've got one down there. There's my pot of parts over there. One sort of there. One this side here. And I reckon that might just do it. Oh, it looks like we're going to have to take the VHF and tuning knob off. Is that now free? Ah, there's 2 there as well. Let's take that knob off. So there's a screw in the middle of there. One presumes. Yep. Let's retrieve that. Excellent. And that should all pull out. Lovely. Oh. I'm not sure which way this hinges now. There's sort of like a hinge piece there. indicating it would all come up this way, which quite honestly doesn't make any sense either. I'm going to go with a first plan. Okay, so it's got stuck in the end of my screwdriver as usual. Got him. Drop him in the pot. Alright. Let's see if it hinges out. And oh, it does clear the CRT neck. Oh, I am glad. Okay. Well, it's all very busy in there, isn't it? Now, we've had a replacement valve at some stage in our life, an EF184, which is down there. So where does our IF come out? So this is the UHF tuner assembly here. That's the antenna in. We've got an output from there, and that's the VHF assembly in. So this has to be, yeah, I think that's our, that's the IF between the UHF tuner and the VHF tuner. Oh, okay. I wonder if it uses the part of the VHF tuner as an IF, because I can't see a switch output. The IF then disappears down here on this piece of coax, which comes out of there. So this is a 625 line picture. As you can see, it's got a lot of contrast there. Apologise for the shadowing, see if we can do anything with that. The problem is this is currently being fed at IF frequency, completely bypassing the tuners from my Philips PM5508 pattern generator. Yeah, unfortunately, that means it's our UHF tuner that's at fault. And I don't suppose we're going to be able to do much with it. There was a warning in the service manual not to. I've also made another discovery, actually, that if I put the PM5508 connected to the UHF tuner and turn the output all the way up, so that is on here just over 10 millivolts of RF into the aerial socket. Yeah, I get a picture. So that's the problem. The problem is with the UHF tuner. So there you have it. Just take that back out again. It is the tuner that's at fault. So we've got nothing to lose, of course, by removing it. It doesn't work at the moment. So why shouldn't we have a little dabble with it? So that's the tuner there. I'm just seeing what needs to disconnect to get it out. And this isn't going to be an easy task, is it? Can't actually see what secures it. It's got to be on the back. Oh, it is. 3 screws. Right, let's liberate those and see how far we get, shall we? Righty-ho. A little bit warm in here. There we go. Right, what have I got to disconnect? We've got a green wire. I'm going to mark that with a green pen if I've got one. Green wire goes to that thing there. Just unsolder that. Okay, we've just got the aerial going in there. That's obviously the HT rail. Might be worth checking the value of these 2 resistors. And this is the IF. So let's just disconnect the IF. If we can. Disconnect the aerial lead. Now, according to the manual, even removing the cover could damage this tuner. I don't want to undo any screws. There's one of these spring clip sort of arrangements here. Let's take that off and see what that reveals. Foam that's turned to rubbish. There's a copper shield, very thin copper. Oh, it's a lekker bar, look. Wow. Wow, 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 wow. So here's our tuning mechanism. So you can see this just a few variable capacitors moving around in there. Gosh. And in between each of these stages here, you can see just in there like a little metal can transistor. And one of those could be at fault. I don't see any harm in undoing those screws actually. They just appear to be holding the cut top on. Of course, this is 1965, you've got to remember, so I wonder what sort of transistors they are. Probably germanium. Germanium UHF. I think I had some Soviet parts that would may help us out here. There we have it. Wow. I need some advanced eyes for this. It's certainly a three-legged device, held in a little clip and everything. So, I wonder if we just put the circuit analyzer on there and see what it makes of it. So I'll do the one nearest the aerial first. Oof, I'm not quite sure I'm going to get on that sensor lead like that. On test, moment of truth. Unknown or faulty component. Let's do it again. Unknown or faulty component. So that's where our fault lies. Bet you betcha. Of course, the tune circuit's still working, but hence it's still working. We've just lost a gain stage. Let's just try this one. Can't actually see. Good grief. I see it. Not quite sure how I'd go about repairing this. Because I really did start with the transistors and build everything else around it. And still. Cannot for the life of me hook onto that leg. Perhaps I'll come at it from this side. That's interesting. This transistor appears to have a fourth leg. Ah, we have success. I am hooked on. The fourth leg is just cropped off though, it doesn't go anywhere. Wonder if it's for the can. Right, analysing. Unknown or faulty components. Yeah. Well. There we have it. We've got 2 duff transistors in our tuner. So what I'm wondering is, so I could just snip that one out. No wonder I've got to put, you know, 20 or 30 millivolts into it to get anything out. Right, I'm just going to snip these. Try and get them out. Where are my pliers? Right, see if it'll just slide out now. I think we may have to remove this. Oh, you see, I wish I'd known about that before. Right, what are you, my little friend? Oh. Gotcha. AF139. An AF139. Right, I'm going to stop this video here. I'm going to get the other transistor out and I'm going to see if we can find an AF139 or equivalent. Right. So, didn't have an AF139 or 2 in stock. Bit of a shame, but there we go. I've ordered some, so hopefully they'll be turning up in a week or so, and we can carry on with the repair to the little Colster brands. I'm just going to take the set outside now and blow it out with an airline because it's quite unpleasant in there. So give it a bit of a clean and a birthday, and yeah, stay tuned, and I'll see you really soon here on Doz's Television Workshop. Bye. For those as well. I've just muffed that line, so let's do it again, shall we?